So guys, Chace is about to go on. There is a panelist talking about commercial vehicles. So Chace is going to go on the next 10 minutes. Hopefully he's got a good interview where he can talk about great points, you know, talk about Topsy, and more importantly answer some cool questions about electric commercial vehicles.
Hello, thank you guys so much for joining. So good to see all of you. Hope you guys are having a good time. You got some lunch and some test drives and stuff. Real quick, how many of you guys first time at a fully charged live show? First time? Yeah, that's awesome. So glad you guys can make it out. We have a really fun discussion today. We're joined by some really great panelists. We're going to talk about electrifying the bigger things in our lives. Which is interesting because a couple of years ago, we've been talking about passenger cars. Now, the best-selling car in the world so far in 2023 is electric, of any variety. It's a Tesla Model Y, outbeating the previous winner, the Toyota Corolla. So that's pretty amazing. But now, how much further can we go? So let's start off and meet our panel. Let's start with you, Glenn.
Right, I'm Glenn Gary, Victoria Electric Vehicle Association. We are a owner advocacy group. We help people kind of wrap their brains around where EVs are going. We also get involved a lot in research. We're a very dedicated research team, and we work with and advise governments at all three levels.
Hi, I'm Dave Sauvé. I'm the Senior Manager of the Urban Fleet Program at Coast Mountain Bus Company. We have a fleet of approximately 1,700 buses that we're looking to convert to zero tailpipe emission by 2040.
I'm Chace Barber, CEO of Edison Motors. I'm a logging truck driver that decided to build my own electric truck.
It's a great introduction. Let's start with, I don't know, who wants to start off? We'll start with, let's see. Let's start with you, Chace. Okay, we'll go in reverse order. So what are the advantages of plug-in electric and hybrid trucks? So you have some experience, it sounds like, from doing this in the past, the diesel era. What are some of the benefits of going electric?
Oh, I've been saying the advantages for heavy haul application are, like, electric is the best for heavy haul logging, like, especially logging in BC. You're going up the mountain empty, you're coming down loaded. So you don't use dick all for power to get back up there. Coming down, you got regenerative braking the whole way down. You use that stored potential energy of the logs to come down. Electric motors are more torquey, more powerful than the diesel, no transmission, no drive lines to blow out. Like, you can get incredible efficiency and incredible reliability in that heavy vocational electric. It's literally, the harder you work electric motors, the more they like it.
Yeah, I think we talk a lot about, yeah, thank you, yes. We talk a lot about the batteries, because the batteries are really kind of the critical bit to sort out, but the electric motor part, no one talks about it, there's a reason. They're really good. Absolutely. Anyone want to chime in? Some of the benefits? Or?
Well, yeah, I mean, the other advantage, the bigger you get, trucks end up spending a lot of time in maintenance, maintaining their systems, maintaining the brake systems, all those sort of things. It means that the truck is off the road, the truck isn't making the money. So if you've got a system where there's very little to maintain, there's very little to take you off the road, that's money in your pocket. It means you've got a truck out there doing the job.
Well, that's exactly it. If you go look at our truck in the back, we built that thing as skookum as we possibly could. Like, because these things are reliable. The downtime is the most expensive thing. Make those parts as reliable as possible. Make that truck last 20, 30 years. We got an old 1962 Kenworth we made electric back there. That thing was hauling logs for 40 years. If you build these trucks as rigid as you possibly can, they can last a really long time. If you don't have to worry about drive lines and all that, you could really make a truck last.
And this stuff really matters because a lot of us, we're thinking about the electric car in our garage. For good reason. I mean, look at the cars around here, there's some beautiful examples. But most of our cars are parked 90% of their lives on our driveways and parking lots, not doing very much. But commercial side of the things, like in buses and trucks, they're working much more frequently. So this decarbonization in a lot of ways matters even more on the bigger side of the business. Dave, how does it fare when you talk about buses? Like what are some of the benefits as Chace mentioned, and what are some of the challenges that you guys are seeing?
Yeah, so we definitely need to be up and running. That's a major part. So if our buses aren't picking up people and transporting them around the region, we're not doing our jobs. So folks in maintenance that are looking at electric buses are very concerned about the uptime. And that's something that I think the maturity of the electric bus, depending on the type of vehicle, the model, it's there, and there's some gains to be made over time. But there's also some vehicles out there that are pretty challenging to meet the duty today.
Yeah, that's a good point. There was a company that I met with in Taiwan that builds electric buses, and what they told me is what they were really focused on was the chemistry of the battery, because we think a lot about range, just like a flat number, how far can you go? But sometimes, depending on the application, it can vary. So, for example, the bus example, you're coming to a stop at a station for 2 or 3 minutes. You know kind of exactly what you're doing. So what they found was much more important than just raw range is how quickly you could charge. So they went with a chemistry called lithium titanium oxide, which is not as dense. You're not going to get as much range, but they can charge. It's the fastest charging lithium chemistry. So we're talking a bus from almost empty to 80% in like 2 minutes. The time it takes to stop and unload and load passengers. So this bus with less range, if you will, is operating kind of constantly. So it's kind of we have to reimagine in a lot of ways. We can't just think about changing over to electric, but there's kind of a reimagining of some of the technologies that are in play. Don't you think?
I think so. I mean, that's not a chemistry that is typical for our battery electric buses. One of the big pros with transit is we've got a fixed route. We know where the bus is going to be at any given point of the day, and we can model our energy as a result of that. So throughout our transition program now, we've modeled the entire transit network throughout Vancouver and surrounding area, and we know exactly where technology is today with respect to those routes. So we know what the success rate is, and depending on the fleet type, so 40 to 60 foot, there's a very good success rate with the technology that we have today. There's some other ones like community shuttles and double deckers that the technology is not quite there yet to get that high level of success rate, but we do expect it to come there. It could be through breakthroughs like you're talking about there.
So, I mean, Glenn, we've had diesel busing and large scale applications. Why do we need to go electric? What's the big impetus to do so?
Two. Both start with E, economics and environmental. So we've already talked a bit about how you can, spend a lot less money in fuel with electric than diesel, and diesel prices are just going to keep going up. Right now, if you ran a diesel Class 8 out for a decade, and you compared it to a similar battery electric truck, you're going to save about 40% in total cost of operation. Okay, so there's the economics, and that's the great thing about business. We as personal, people driving our personal vehicles, we can make a lot of emotional choices about that. Business, they turn around and go, what's the bottom line here? Are we going to make more money with this than our status quo? Have more time on the road? Then yeah, they're going to do it. They really don't care what it's being run by. The other one is environmental. Big diesel trucks are only 5% of our population on the road. They're half of the pollution on our surface transport. That's a huge impact, right? You got a diesel truck burning 50 liters per 100 kilometers, right? Or more. Or more. Really? I was being generous.
I get about 80, 90 in the login when it's just diesel only.
Oh yeah, and and that is 130 kilograms of pollutants coming out that we all breathe, because most of those trips are done in urban environments, less than 250 kilometers, right? That's all stuff we're breathing in. So, long and short, economics and environment.
It's a great answer. I don't know if you guys have noticed, but there are cars right over there that are running, but you don't hear them, you don't smell them, they're operating quietly and electrically, and it's something that we didn't even think about, but that's been happening this entire day. And somebody mentioned earlier in a previous panel, how many of you guys have electric cars? It's a lot, that's good. So have you ever seen one of these big, like Amazon delivery trucks or something idling in front of your house, just spewing away as they're making their transit rounds, right? Or refrigerated 18-wheelers that have to keep their cargo cold, and they have to just keep their engines running constantly. All that kind of gets solved when you go electric. To your point about economics and the environment, it's huge. I was in a traffic jam recently, and I was starting to get a headache just from the fumes, not moving, and all the cars just polluting on the roads. it's the health component we don't think about very much, but it's a huge part of it.
You don't have biohazard mode on your car?
I do now. My early Model 3 did not have it, no. But it does work really well.
Literally, it filters on everything that's coming back at you. It's a huge HEPA filter, so yeah, it's awesome.
So Chace, tell us a little bit about how you got started and what gave you the onus to start.
Honestly, I saw the benefits of electric, like I said, going uphill, empty, downhill, loaded, and I reserved a Tesla Semi like 5-6 years ago. Me and my business partner Eric, we were one of the first ones to reserve one. It says like number 4 in Canada. Gave him the money for the deposit. After waiting for 5 years, I got so annoyed that I said, screw it, I'll make my own truck.
Kind of walk us through a little bit, like what kind of motors, what kind of batteries, what do you got?
Okay, yeah, so we've got 180 kilowatt hours of batteries, and then we got E-axles for the motors, each at about 350 kilowatts, so we got about 700 kilowatts, 800 horsepower to those wheels, which is 300 horsepower more than a normal diesel truck, so you're getting way more power. Then one of the problems and why we went with hybrid was range. So a logging truck uses about 2.5 to 3 megawatts per day of power. So you put in a megawatt of batteries, you're still 3 times less than what you need to be. So what we realized we could do is there's a huge peak power demand in the semi-truck. When you get that initial inertia moving, taking all that mass, getting it up to speed requires a ton of power. Maintaining that momentum doesn't. So a huge peak power demand. So by going hybrid, we were able to meet that peak power demand with the batteries, give it a shove off the line, and then the generator on board is basically, I like to call it a fully electric vehicle with its own onboard fast charger. But it recharges the batteries as you're going, and the generator meets that a little bit above that average load. The batteries meet the peak power demand, and you get a massive increase in fuel efficiency because you're, instead of running a 16-liter engine, you're down to an 8-9 liter engine. So you're running half the size of the engine for 50% of the time. Interesting.
So is the drivetrain purely electric and the generator is just charging the pack?
Yeah, the drivetrain is a 100% electric truck. It just has its own onboard level 3 fast charger.
Wow. And combined with regenerating downhill.
Exactly.
See, that's part of it. Is we talk about cars because cars make a ton of sense. Anybody who has a gas car today, go test drive one of these cars. You'll find a car that you really love, and we're ready for that today. But we often think that these bigger industries are just so far out of reach that we can't quite electrify it yet. But there's a lot of steps on this road. It's not, we don't just flip a switch and go from diesel to pure electric, everything, this utopia. We evolve, and that's an incredible example. Are there some kind of stories like that or examples in the bus world? You mentioned that the very predictable route, you know where you're going to stop.
Yeah, like I think just leaning into what they've exploited here about going downhill, I think there's areas to be explored about understanding how much energy is going to be used during the route and actually designing the routes to fit what this vehicle is capable of. I think right now we're looking at it and going, okay, we have this fleet of 1,700 vehicles, we have all of the blocks for it. How does it directly fit one-to-one? That's kind of the position we're in right now, but what you're kind of highlighting and what you've been able to exploit there is you've taken a weakness that is like less onboard energy and been able to turn it into a strength. And I think that is an area that, if we consider the lower mainland, we know that there's hills there. We know that we can be redesigning our blocks in a certain way to kind of take that into consideration.
We were talking a little about solar panels before this too, but there's a huge opportunity there. If you have a bus is just a massive solar canopy, right, waiting to happen. Big rigs and logging, potentially, maybe?
Oh, well, we were working on, actually, one of our solar light towers is out in front of the building there. But we're working on a project where we're taking a 53-foot trailer and we're covering that entire damn trailer in solar panels because there's a ton of space on the entire roof. We did the math, and you can run a reefer off of the electric power that the solar produces. A lot of these trailers are parked or they're going down the highway in the day. Why not take that energy that's hitting it? Because every reefer is essentially an off-grid power plant. That's what they are. They're running a diesel to make off-grid power. So why not optimize the off-grid power? It's one of the best uses of solar. If you can put in solar and replace diesel, that is the best use case of solar. We're putting in solar here, but we're on hydropower. Well, that's already pretty clean power. If you put those solar panels on the top of a trailer that's running a reefer, you're really cleaning up, but that's the best use case of the solar. Plus then the trucker doesn't have to listen to a damn reefer behind them.
Yeah, and the reefers, the diesel reefers that are on there, they're not as clean as a vehicle at all. They don't meet any of those environmental standards. They are nasty. So yeah, getting to a pack and you're running that reefer electric, and because essentially it's a heat pump on your trailer, is what it is.
That's exactly what it is.
So what are some fun facts in your various industries or just in your time in this electrification journey? What are some fun facts you've learned?
So transit is an interesting industry. We're kind of one of the leading heavy-duty trucks to industries to electrify. We also don't have any competition. So there's transit agencies across North America and Europe, and we're not competitors. We actively work together and share all kinds of knowledge and all kinds of skills on the same journey that we're all on. So it's a really rewarding space to be in when we're taking on such a large problem. This is a pretty significant problem here, and able to work on it together, I think it's pretty amazing. And even branching out to our industry partners as well, there's a very good dialogue that occurs between us and industry and us and the transit agencies.
Yeah, and there's some interesting stats when you pile through the data that Department of Energy, Transport Canada, and a lot of these other groups have. You can pull out some really interesting numbers. Chace here is, he's working one of the specific use cases in logging and stuff, and really heavy loads. But if you look at the vast majority of Class 8 trucking, most of them are not running at maximum load weight. They're running at maximum volume weight. So they still have a lot of excess weight to the vehicle. Something like 95% of all truck traffic in North America Class 8 is 800 kilometers or less. 84% is less than 400 kilometers. So, it's going to get to a point where you don't need a megawatt of batteries to do a lot of the work, right? And that means you're not spending the money up front for a battery. You're spending less time when you're charging it, hopefully at a megawatt charger. So it works into your break schedule for the driver. You're spending less money all the way around and getting a far more efficient truck.
Well, I think that really touches on is that there's no one solution to a transition. Like there's no one solution. Maybe a little bit of hydrogen, maybe full battery electric, maybe hybrid. There's going to be different use cases for different things. Like I say, a lot of these trucks could go full electric. A lot of them could go hydrogen. A lot of them need hybrid. We need to just change our mindset of thinking that there's a one-stop approach.
That's a really good point. Imogen had a really awesome episode here in BC. She went to a mining facility and they had these ridiculously massive, I don't even know what those trucks, what do you call that? I don't even know what that is.
Them big mining haul trucks have like 14-foot tall tires.
She has her thumbnail, she's standing up, and she's like the radius of one of the tires. So you just imagine it's like a 10-foot tire. Just incredible scale of these things. But what they had done, and I thought it was so brilliant, is they realized there's a lot of driving around to collect and things. That is still diesel. But they have these overhead lines that they run. And so as the truck gets to this route, fully laden with all the materials, they engage this contact patch, and it runs on electrical lines like the old-fashioned buses and like transit buses, right? And so
they're not
all of that
old-fashioned.
transit, what's that?
They're not old-fashioned.
Sorry, that's not the right word.
75 years old, but they're not old-fashioned.
What we've established for so long. That's right. I thought that was just so brilliant because they were not ready to completely go electric because they're very remote. There's challenges that they had, but the emissions reductions were, as you can imagine, Chace, they're enormous. They went, I forget the numbers. It was like a 90-95% reduction just from that little bit of technology. They're just so clever about it because they could eventually wait for the batteries to get there. But their ROI for this system is incredible. It's like it pays for itself in no time, right? Pretty amazing.
Yeah, why are we waiting for batteries to be perfect when we can implement real strategies like this to reduce things now?
That was the question of 2005.
So we would love to hear any questions you guys have. So there's a microphone right up here, so feel free to make a cue if you have a question for us while we just kind of keep chatting. So have you guys been, what are some of the industry trends that you see, maybe like Tesla Semi or some of these bigger industrial applications coming online? What are some of the trends you see in going into the future?
So we talk about trying to fit an imperfect technology into what we can do today. So right now we've modeled our fleet, and there's a big difference between if you do hybrid heating, which is electric heating, electric-resistive heating, as well as fuel-fired heating, and just pure electric heating. I think we all know that our baseboards in our house aren't very efficient, and we've got incentives to put heat pumps in our house, and that's when we've got like lots of insulation, we've got small doors that stay closed, and we have this infinite power supply that comes to our vehicle, or it comes to our house. And on a bus, we've got these basically no insulation, we've got large doors that open all the time, and then we have this really finite amount of power that's on board. And some of the policies kind of force us to go into, force at least folks in the US to go towards just electric resistive heating. And because there's no heat pump option for automotive for the most part in our bus industry. And so right now I'd say, can we make do with hybrid heating? I think there's a lot of advantage there, but where the trend needs to go and to where we can purely like walk away from this would be to get heat pumps on board with our vehicles.
Sounds like an RFP you need to write.
You want to help me write it?
Yes.
I think it's going to happen soon. You realize, I think a lot of the car companies are switching over to this. Most Tesla models now have heat pumps for heating as well. And they've integrated this entirely brilliant system where they take waste heat from every component, batteries, inverters, DC-DCs, and they take all that heat, and instead of just dumping it, they use that for the cabin heat, or like kind of repurposing heat as an energy source, because heat is one of the primary sources of energy. So I think it might be coming soon, you think?
Yeah, I think it would be really helpful if it did. I mean, a car, we typically keep car doors closed. If it's cold outside, we close the windows. With a bus, we have to pick people up and have to let them come off. It's a big space to warm up, and it makes a big impact. 20% is what we're looking at in terms of success or fail.
Yeah. Looking at trends, though, 7 years ago, if we'd done any of this, there were no truck companies that were investigating getting off of diesel. None. A leading company decided to lay down the gauntlet, gave the trucking industry, here's the bar you're going to have to jump over because we're going there. Look around. A lot of big makers out there are now building electric trucks. That's the trend.
I have my question for Coast Mountain Bus Company. I noticed...
Look close to the mic.
I noticed that you guys are getting the new Nova buses over the new Flyers. Why?
So I think too much to say, but we have an RFP process that goes through, and there's certain specs for the vehicle, and there's a number of requirements that they get evaluated against. And there are some great manufacturers in Canada that make buses, and this just so happens that that the Nova buses that are coming at the end of this year and into next year will be Nova LFC Plus vehicles. We have a number of new Flyer buses out there, and we're quite happy with them, including 2 of the battery electric ones.
Thank you.
Do you think it's better to focus on one section of electrifying commercial vehicles, or would it be better to continue on a wider spread? Because you can focus down one section or continue with
Well, I mean, when it comes to commercial vehicles, they're all pretty well the same. Commercial vehicles are standardized. Since 1954, every single commercial truck's had the same 32-inch wide set of frame rails. You can put a gravel box on them. As long as the drivetrain is really what you're electrifying, the truck don't care what you throw on the back of it.
It's a really good question. That's actually a really good question. I've thought about this myself. I think part of what makes sense to just diversify is you never know when there might be like a breakthrough. Maybe there's some new chemistry or there's some new use case or something that compels the industry above others. So if you invest widely, you get the best chance of success, right? Because different industries might electrify at different times, but if we're looking at all of them, we have a kind of the best chance. It's a great question. What a good question.
Hello. Question for the panel. I have over 200 commercial vehicles, and for all of them, I know the end of the life cycle. I know what's going to happen when we have program in place. What's going to be the end of the life cycle for the electric commercial vehicles?
Great question, and that's something that, because the vehicles haven't gone through a full life cycle yet, it's hard to tell. So in the bus industry, we're looking at, right now with our current fleet, we've been able to extend it to about 17 years for a diesel fleet, and that's through like really good maintenance practices and doing lots of fleet overhaul ourselves. For battery electric, it's a bit of a mystery. So for us, it's hard to tell until we get there. But we're kind of leaning on what OEMs and what the kind of recommendations are around North America. And that's leading us to be about 12 to 14 years is what we can expect from that. And we'll see what we get when we get there.
Is there any programs in place right now for batteries?
Programs to do
for recycling batteries at the end of the life cycle?
Yeah, so recycling batteries, it's kind of like a chicken and an egg issue at the moment. The batteries we've been putting in cars, like we'll take the Leaf. A great car with today we look at it as the worst battery in it possible, mainly because it has no thermal protection for it. It's not very dense, but it's on the road, and we kind of thought about 8 years in we'd start seeing them fail and that they'd then have to go into a lot of warranty work. That hasn't been happening. And that's the worst battery out there. Okay? Everybody else, they've moved on, they're taking care of the batteries, the car. It's like a baby. As soon as they're born, they start to breathe and they're taking care of themselves. And so batteries are lasting a whole lot longer, and the recycling industry is taking long to get up to speed because those big batteries are not there. They're using commercial devices to get ramped up.
Well, instead of just worrying about the car too, like just the batteries in the car, why don't we worry about the whole rest of the vehicle? Because there's a big trend where all these commercial trucks you're getting more and more planned obsolescence. You might be worried about the battery, but why are we building trucks that only last 5 or 6 years nowadays? It used to be you could buy a Kenworth, you own that Kenworth for 20 years, go to work, that thing would last 20, 30 years. You buy a truck now, 5, 6 years, you got to throw the whole truck out. We worry so much in an electric vehicle about just the batteries, but what about the rest of the truck? How come we can't build them like we used to?
That's a good point. We have one more question? All right. Great question. One more question. This is the last one.
With how you can get a lot more torque and everything from an electric vehicle, would that increase like load capacities for long haul trucking, or is there still like a limit on just because the length of the trailer and everything on what you can get on the roads?
Yeah, you can increase the load capacities. With more torque, you can move more weight, but the scales aren't going to let you do it. The only saving grace is BC gives you an extra 1,500 kgs to offset some of the battery weight, but off highway, yeah, you can get those weights up. With regenerative braking, better holdback, better torque. If you're off highway, you can bump that load weighting right up.
Yep. Most states and municipalities have weight limits for the roads, because I mean, you can imagine the wear and tear that you're putting down the surface. I think we are at time, is that correct? Thank you guys so much, and how about a quick round of applause for our wonderful panelists. Thank you. Have a great rest of your show.